In this video, I'm going to overview the lab that you just did, the activity you did, the data you collected, and I'm going to show you how you can answer the questions to help you make sense of this whole lab. So in class, all you were able to do was collect data. So I'll overview that too. However, if you're watching this video, then you're probably trying to finish the post-lab questions. Now, before you do that, make sure you read very carefully the first 2 pages. There's a lot of good information in there that you will use later, especially this background part. Okay. The whole goal of this lab was for you to launch a rocket, estimate how high it went, and then we are going to use Newton's law of gravity, his law of universal gravitation, to figure out what the force of gravity was between the Earth and your rocket at the peak of its launch height. How much gravity was pulling those two things together, pulling the rocket back down to Earth? So the first thing that you're going to need is your data here. You should have done at least 3, if not 4 launches, but how did we understand, or how did we get what the launch height was? So for this one, we're going to estimate a little bit. You launched your rocket from this little platform outside of the back door of our school, and it went straight up. Turns out that the siding on that part of the building, those slats are about 1 foot apart, maybe a little bit more. So we're just going to estimate and say that 3 of those is 1 meter. Another 3, that's 2 meters. Another 3, that's 3 meters. The last 3, there may be more than in this picture, is 4 meters. So when you launch, I explained this in class, you had to make sure someone was watching how high it went, and you're going to count the slats. And now you're going to change that into meters. So your data should look something like this. Maybe you got 2.5 meters. I'm going to draw it. It's a lot quicker. 2.5 meters. Maybe you got 3 meters on your second. Maybe a short one, 2 meters on your third. Let's say the last one was really high. But now we're going to get the average of this. So you have to add them all up first. 4 plus 2, 6 plus 3, 7, 8, 9, 10, 11.5. So you have 11.5 meters total. Now to get an average, you have to multiply by how many launches you did. 1 divided by 4. Let's see what that answer would be. 2.875. So now listen, this is not your data. You should not have these same numbers. I am just showing you how to do this. Your numbers will be different. If you have the same numbers as me, then I know that you just copied off of this video. So do not do that. 2.875 meters. All right, then it goes to a series of questions. What is the equation for Newton's law of universal gravity? To do that one, you should look up on the previous page. The value of G, you should also look up, if not in your notes. I have G right here. G is 6.7 times 10 to the negative 11th. The mass of the Earth, I give it to you. I'll give it to you in this video in a second. And the mass of the film canister. So I weighed this. The film canister is about 8 grams. However, we know that the masses have to be in kilograms. So 8 grams is about 10 to the negative third. So 8 times 10 to the negative third kilograms. So that's the weight that we're going to use here. Okay. Your average launch height, you should have it from up here. Mine was 2.875. And the next question, meters, says use the above information to calculate the force of gravity. So the R in our equation here is the distance between the Earth and the object you're trying to figure out the gravitational force of. So in this case, we're doing the maximum launch height of our rocket. So that's going to be the average distance or average height that you got. So for my example here, I am going to use, you should use a different number, use your numbers. I'm going to use 2.875 meters. So now I'll walk you through how to do this. So F equals G, 6.7 times 10 to the negative 11th, times 5.97 times 10 to the 23rd kilograms. That's M1, that's mass of the Earth, times 8 times 10 to the negative third kilograms. That canister is very light. Divide it all by 2.875. 2.875 meters. All right. So I'm going to have to draw this kind of small. But over here, what do we end up with? So I want to just pull out, I don't have a scientific calculator, so I'm going to pull out all the exponents. So I'm going to have 10 to the negative 11th times 10 to the 23rd. You just add exponents. So that will be 10 to the 12th. Then add negative 3, 10 to the 11th. So times 10 to the negative 11th over here. I'm going to erase some of this stuff. So we just pulled out the exponent there. If you have a scientific calculator, you can do this. Just plug it right in. But I'm going to do it this way to make it easier for myself because I do not have a scientific calculator. All right. And now all I got to figure out these parts here. So 6.7. Let's go back to my calculator. 6.7 times 5.97. Whoops. Times 5.97 times 8. I believe that number was. Yep. And that equals 319.992. All right. I don't have any room, so I'm just going to erase. You should write yours underneath. $319.992 times 10 to the negative 11th. Okay, and now we are going to divide that by 2.875. Okay, let's do it. Divided by 2.875. 111.301. So our answer is 111.3, I believe 0102 times 10 to the negative 11th. So that is newtons because force, the F, is in newtons. So this is the force of gravity between our canister and the Earth at the peak of its height. Now let's draw that out. If it's 11.302 times 10 to the negative 11th, what's that number really look like? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 0.000000001111302 newtons. So as you can tell, the force of gravity between the canister and the Earth is actually pretty small, probably because the canister is very light. Now for the last part of this assignment, it says, and I'm going to stress this, read Newton's 3 laws of motion in the beginning, these, and read through the background activity. Here, lab background activity. So what you're going to do is, you're going to tell me what parts, which statement here correlates or shows each of Newton's laws. So the Newton's law, an object at rest will remain at rest unless acted on by an unbalanced force. Which statement in here is an example of that? And you're going to do that for all 3 laws.